Welcome back to the series where we were talking about a full stack agentic system, and this in particular, in this video we are trying to cover how a AI agent reliability and QA test suits can be written, right? I mean, if we can do a TDD, then that is that's a golden standards that we have to try employing. But otherwise as well, how do we make sure to write a integration test suite? What are the additional layers that we saw in our previous kind of the architecture, right? The entire architecture quickly to give the glance, right? So let's see what did we discuss. We saw that there were two more layers that got added as part of this, which was an agentic brain, which was a graph, and then there was a thin tool structure, right, as part of this. And if we see this right, if we see this, these were the two layers that got added to this. So now let's see how we can test this, right? So testing involves you can approach it via a TDD approach as well, or if there is an existing test suite already and you are trying to introduce an LLM layer on top of it, how do you write the test for that? So it can be at a later point in time you are trying to make a quality assurance upon it, an automated test suite, so you can try doing that as well. In both the case, the principle remains the same. Those principle is something which we gonna concentrate on. And again, this is not a code walkthrough, neither kind of a pair programming session. It is basically to understand the concept. Maybe if ever time permits, we can try doing one TDD at a later point in this playlist, but not in this particular video, right? So quickly, so with that said, let's get into where is that we are trying to explore with this this particular approach with an example, right? So this is the place. So in server, if you see tests, I would have written this as part of as part of in the description. I would have given this link, so you can refer to that. I will also give you the checklist, this checklist which we're gonna have a quick walkthrough as well, so you can refer both of this. And whenever you are trying to make a test suite ready for your particular agentic full stack needs, you can refer to this checklist and also these sort out examples, and then try to make your own test suite architecture ready for at least a beginner level of a basic to intermediate level of test suite ready for this, right? So I have used vtest for this particular test suite. So you can see that I have made an integration test suite. So I haven't tried implementing a unit test case per se, but then we will touch across the unit test principles as well for agentic system. But as of now, I have implemented an tools integration tests, right, and an LLM integration test. What is LLM? LLM-as-Judge integration test, right? So that those two, and then there is something which I have covered as an infrastructure. That is something which was a conventional one. It has nothing to do with your own this agentic system, right? So what I am trying to express here is this simply, that you have your test suites in your repo already. Now two more layer got added. So yeah, let's build the intuition here quickly if that is not the case. So what I will do is I'll take a, so this was my entire architecture, right? So here this was one more, right? So this was one more, and there was one more, right? Likewise, so this is, let's say, our repo layer, correct? Okay, this is way small. Okay. So we'll say this large and extra large. Maybe I have zoomed out at a very high level. I have zoomed out. So this is a repo layer, and then this was a service layer, right? Service layer, and then this is your controller. So this was it. So this was our conventional system that was handling an API endpoint so far before to LLM introduction. Now two more layers got added to it, which we saw in the architectural simpler diagrams, that there were two more layer got added. One was a graph layer here. So if I have to switch this, right, so let's say I'll put this over here on the top, and here this was the second layer, that was service, right, and here one more layer got added. The width and the scale has nothing to do with how critical or how finer these are. It is just a diagram to understand the blocks that were involved or the tires that were involved. So the first that got added was, what was the first that got added? Simple, which was, it was a graph layer, your lang graph layer, or an agentic, where you introduced a kind of, if you see this, if I go to server and if I check the source, right, quickly in the source, you see that there was a layer called as expense. This is an expense agent. So this is that graph, right? So this is that graph that got involved, which is in turn called by a controller. We saw that there was inversion of control. We saw that there was kind of dependency injection that we made sure that we will make use of it. So in the controller, if you see, if you go to the chart controller, you see that this particular chart controller makes use of a compiled graph. And where is this compiled graph getting from? So we are getting this from what? From this expense agent. So where did we instantiate that? In the route section. So if you see this in the chats.ts, you see that there has been an expense agent builder, where we have at a later point, like kind of a lazy compile, we are trying to do the check pointer initiation at the very outside of it. But all in all, this is the graph builder, and this graph is what I'm talking about here as a agentic graph, right? So this is an agentic graph. Let's say that this is an agentic graph. And one more thing, this agentic graph, there was one more introduction of it, which was a tool layer. So agentic graph will again have tool consumption or an init tool consumption. We would have initiated the tool, and then we will give this tool to the graph to use. Like graph would then even have a dependencies on the LLM. If we have quickly, if we recall that, the expense graph builder is dependent upon your LLM, the tools, and the system prompt. That is, and it is of course dependent on memory saver or a check pointer as well. While we compile, we are trying to give, but all in all, we are trying to give an LLM and these tools. So this is something which we had discussed in detail. Now, in your existing entire architecture, what you might be having is, you might be having already a controller test suite, a service test suite, or a repo test suite. So with that, where you are trying to reliably make your API or your stack more reliable and quality assured. Now, how do we write tests for agentic graph and tool in this thin toolkit, which internally consumes this service and then the later repo? So the test for these two have already been taken care. If not, you can write it up in a conventional method. So, and controllers is already something which is already taken care. Now, how do you write something for a non-deterministic system kind of an LLM, where agentic graph will contain internal node called as an LLM, and for a tool which will be consumed by the agentic system? How do you unit test the tool or integration test the tool onwards, that is tool, service, and repo? And how do you, since this is an LLM that is involved, how do you test this using LLM-as-Judge for the LLM to call about the tools and in turn consuming the services and repo? So we're gonna discuss the unit tests for this and the integration, and same goes with LLM-as-Judge, the integration and the unit test for this, right? You understand the concept of unit test, right? So unit test means only this particular unit is getting tested. Integration test from tool onwards means that tool, service, and repo getting invoked altogether. And the similar goes with unit only for the graph. And what is that we're gonna test in graph is something which we're gonna discuss, and the integration from here onwards. That is something of an LLM-as-a-Judge concept, at least to bare minimum to begin with, right? So let's go to, so I would try to highlight this if it is possible. Yeah, this layer, and this layer is something which we're gonna touch across. Right, now what are the stuffs? Let's go with this test. Yeah, this is that test. So I have simply implemented an integration test suite. I haven't went into the nuances of getting it covered in unit test. In some of the tools I have covered the TDD approach. Yeah, so that is something which we will discuss about. So first we'll have a 3-pointer checklist for this. You see that there is unit test and integration test, as we said, and there is a production evaluation. What is that? We will see the entire goal. So what is the goal that we're gonna go with? The goal is to decouple the brain, that is the LLM, from the logic. Those are what? Tools and graphs, right? Obviously this is a tool and this is a graph. To decouple our LLM test suits from this and test them. Test what? Test the tools and the graph independently, so that we ensure the reliability without burning additional tokens. What is that happens? So first we'll see that. So in conventional way, if we have to test this agentic graph before hitting the production, what will happen is, if there is an LLM involved, let's say we are trying to test it out, we are writing an integration test suite, or for that matter unit test suite, and there is a live production LLM that is being involved in this test. Let's say what will happen, each time you make a round trip, ask some question or ask the LLM to perform, or an agentic graph to perform a certain task for you, that workflow will gonna utilize the LLM, and that LLM gonna be your production LLM. It will involve what? It involve consumption of tokens, right? So that's the costliest affair, correct? So now with that said, how do we decouple the LLM out of this agentic flow? How do we directly test the tool? First, let's test the tool first, because the LLM is involved in this agentic graph. If we can solidify and harden our toolkit, which gonna be consumed by the agent, then we are halfway done with our battle, right? So how do we test the toolkit first, and then later jump into the agentic graph system? So first let's see how to write the tool test. So what are tools, right? If you see this, let's go with first this one. So tool schema hardening and the arsenal. So I meant to say here the arsenal is the tool arsenal, right? What do we have in the tool arsenal? We have a Zod scheme validation. Let's quickly see the tool tests, right? And we'll also see, if possible, how are our tools structured. So in our source, how do a tool look? So tool look typically like this. Tool is internally dependent on service, like explained in this particular flow, and within this service, the tool is calling what? It's a thin layer of what? Thin layer of Zod schema validation, whether the input generated by who gives this input is given by the LLM. So it validates that and quickly calls up our service logic. That's all. That is how thin that we have kept it, that which we discussed why we need to keep thin, right? So with that said, this is how the tool looks. Now these are our tools like get expenses, get expense chart, and all the others like insert, add expense, right? All these are our tools. Now how do we write quickly the test? Let's see the test architecture first for simple tool integration, right? Go to this integration and tools. If you see this, there is one important stuff that has been written. If I have to quickly give you that vtest config test, so that gives you the idea. So this is my vtest configuration. You can use any framework, you can use Jest or any other stuff. Just vtest was an improvement over Jest is what I felt, and then I used vtest for this. So quickly in this vtest, you see I have segregated into two independent projects. One project which evaluates my integration tools. I have written a global setup for that, and a setup file that gonna run for per test, per tool. I have segregated my tools test into add expense tests, get expense schema. This is one tool, this is a second tool, this is a third tool, right? You need to just, so I have made sure if it works for you, if you can segregate your test suites and your test files into individual tool level, at a tool level. So this is tool 1 test, tool 2 test, and tool 3 test. And then there is a global setup which runs once per running all the tests, right? And this tool setup runs per test, as in per test file. So before calling the add expense, once the tools.setup gonna be involved, right? This is a typical vtest kind of an architecture, the configurations which I have written over here, right? The rest all are simple. If you want an environment variable, we're gonna make use of this environment variable. Now let's get into the global setup. What's happening in the global setup, right? Since we are dealing with what integration tests here, in this particular example we are into integration test suite, right? In the integration test suite, what will happen is we're gonna test this entire flow, right? This service and repo will already be involved and connected to our toolkit. So while we do this, we have to make sure that the DB that we are trying to touch across, so let's quickly have a DB here, right? So this database that we are trying to touch across is not the production database. So for the test architecture, what we have to make sure, that this is something of a what? This is something of a test DB. Oh god. So this is way too large. Okay. I think, yeah, let's ignore that part and write a test, write the text here, call it test DB, right? So this is a test DB, and this test DB, as with conventional standards, right? This test DB what should be a separate database sitting on your cloud provider if you are using a cloud, or a premises if you are using a on-premises test. So but then it need to be altogether a new instance of your production database version. So how do we do it? So we maintain a separate migration script for this, and then I have used an SQLite in-memory test DB for this, right? And I have tried to configure that test DB in my configuration folder, in my global setup file. So that is one particular hack. So this is that side. This is particularly in-memory integration. You see the test tool service and DB flow using an in-memory SQLite instance to verify data mutation, so that whatever the tools that in the test takes care, the workflow that it executes, the integration test that we perform will be performed, and mutation gonna happen in our test DB instead of being in a production. That is first checklist that you have to make sure. This is in-memory integration. That is something which I have done. So what you can try doing is you can try to segregate your test DB into a certain separate environment and configure that setup in your global setup.ts, where I'm taking care of all my production migration. So whatever the migration, since it is a DB first approach, what I have done is the migration will happen however in the similar way that it happens in the production system. But this migration will now be targeting my test DB, which is, in this case, it is an in-memory, right? So that is what happening in global setup. I am trying to migrate all my DMLs and DDLs, if there are any, into my test DB with a convenient name. In what do I do it in tool setup? If I get into tool setup part, what I do is particularly a cleanup particular to the tools. So if I have to invoke add expense tool, if the test suite is running for the add expense, whatever the cleanup that I have to do as part of life cycle of this particular execution of the test, I have written a simple, that is to truncate, to delete the test DB and close all the connection. And it should do what? Here comes the important stuff, that it need to instantiate my services, my local DB instance, and my toolkit, which was taken care in case of running a production variant of this in my source folder. If you just go quickly into this, if I go to the chat root, so here this was taken care by my router or my IOC controller. But whereas in this part of the word, in the test part of the word, it will not be there. Who has to take care? My setup files need to take care of injecting such dependencies. So while I inject these dependencies, I have to make sure that the injected DB test dependencies are very local, as in it is not local, as in a test DB integration that I have to do. Once you are done with that, so once your test DB is configured, what you can try doing is you can configure the service to point and consume this test DB instance. That is what the next level of expense service, here it is getting injected with the testDB, if you see that. And through that comes out the tools, because tools are internally dependent on what? Tool is dependent on service. So now with this, if we write an integration test for the tools, what will happen? It will go ahead and then hit our testDB. We can verify, we can create a situation, we can create up the state, initial state for the tools, and verify how tool corrupted that or mutated that state, right? What do I mean by that? Quickly, if I have to go. So let's get into one of the tests, right? So add expense test. It's a simplistic test. So what do? I get the tool name, and what I do, I mock the input. Let's say I'm trying to add an expense. This, since it's an expense diagram, what I am trying to do, I'm trying to add a copy of the amount so and so. And what I do is a typical arrange, act and assert scenario, and see that whether in my database, which is this database, this is a testDB database, right? Test database. I verify that it has been added to my expense schema or not. Simple as that. So with this simpler setup, what did we achieve? We attained a test suite which is responsible, tests which are responsible for our tools which will be consumed by our agents. So far we had tests for services and repo. Now the tools indeed will have a conventional, these are deterministic nodes, right? So we can write it as similar to that of how we had written to a service or a repo. Simple in this way. Right. Once we make this, so we are trying to check the side effect of this isolation, confirms the tools interact correctly with the domain services without affecting the live production data, which we made sure that by having a testDB and services getting injected with this testDB and internally using this via tools. Now what we can try to, this was as part of integration tests. Now how do you write a unit test? Here, since I have not written, I will try to theoretize that. So in this particular tool, you have to decouple, you have to mock your service and rest on from there. So how do you mock your service? Since it is an injectable dependency, you create some instance of a service and you inject that. That where you have to inject, you have to clearly, if you go here, right? If you go here in the tools setup, you can create literally the mock of an expense service. All that it will do is, it will say that the following expense has been added. It can just return whatever the tool expects it to be written, right? So if I just say this so and so particular tool has been added, if I just say that, so what at the end of it, what is that something which I gonna verify by the server's end? If I go to the source, what is that completely that it will be covered as part of this unit test? So if I go to the tools, right, toolkit, here this entire flow will be tested, right? So what is particularly that it is testing? This particular schema validation, whether if at all, if I ever have to, if you see this particular logic, yeah, this one, this is what important here is. Why to write an unit test is something of an importance for this get expense. Why? See, if ever a schema will be, this schema, a query and maximum number of records, this particular schema will be triggered by whom? Will be triggered by the LLM. It will try to, in any case, if you don't understand this logic, that's okay. So these tools will be consumed by whom? These tools will be consumed by the LLM. The LLM will generate the arguments for this particular, for consuming this particular tool. And if at all, if it has to go rogue, as in if it has to generate a corrupt arguments, what should our tool ideally should do? It need to call with that particular, it need to, let's say it called the service underneath it. So either service need to handle that so and so particular input arguments were wrong. Either it has to do that. In this case, this is what's happening because it is a runtime evaluation. Otherwise, our schema need to take care of it. Here, the unit test preferences, the service level of implementation validations will come into picture if there are integration test suites are involved. But here, what is that we are trying to evaluate as per our unit test? We will try to evaluate upfront that whether the query meets the particular standard or maximum number of records meets the particular standard. And if at all it is not the correct way, if the schema, the Zod schema itself complains that this is not of the string format, this is not of the number format. If at all, if it is a number format, there is a range provided to it. It is not positive in this case. If I try to give up a negative scenario, so you can try playing around with unit test with all trying to fail the schema validation logic written in Zod. So what will happen with ultimately you will try to unit test with mocked up services. You will try it, if at all, if ever LLM has to generate a wrong stuff, whether my schema validation, Zod schema validations are in place or not. With that, what will happen if at all an LLM ever generates a wrong thing, your schema validation gonna get hold of it. You have a test ready to, basically it is giving you a proof that this particular test is taking care of it. That is what a unit test for the tool will take care. So we discussed quickly unit test for the tool and integration test for the tool, and this is a live example. I would have provided this link in the description so you can check that, and this is what a typical the checklist looks like. Right, next let's go to the next one, the bigger one, that is how to test your integration test your first. Let's go with an integration test of the agentic graph, and then we will try to single out this graph and make a test for that as well. Right, so now how do you write an integration test? So far what has happened, repo is unit tested already. Let's mark it green if we can, so that it is done, and this particular service is already done as well. Right, and controllers were already in place. Right, now tool is something which we took care of, attacking the testdb underneath database. Now how do we write, very importantly, how do we write this agentic graph integration test? Now if you look at carefully what is an agentic graph, if you look at that, right, so source, if I look at this expense agent, what is this? This is a non-deterministic node, right, because it involves an LLM inside it. So we can't conventionally write and assert with our conventional vtest. It will then be a full of regex expressions. You're getting it? Why? Because the tone will be conversational tone output from such models. If you have to ever write a test for a graph which involves an LLM, what is the output of it? The output is typically a text-based conversational output that I have executed in so and so tool. This is what the outcome, this is what the analytics is. So this will be returning in that fashion. Then how do you write tests without having to aggressively write up a kind of a regex pattern? How do we do that? That is where LLM-as-Judge comes into picture. What we will do, let's go one by one. So let's go to the place where we have written this. So this is that LLM suite. So in the global setup, if you see, again I am trying to set up what's the first thing that we have to do. We have to set up this testdb. That's what we are trying to do here. We are trying to set up a local DB client, and we are trying to migrate all our database objects into that particular testdb. And then in each setup, what we are trying to do, we are trying to clean up and have a typical lifecycle management, where here we will have the actual toolkit. Since it is an integration, this is an actual toolkit, it's not a mocked up toolkit. We will have an actual service layer but with a testdb inside it. So that is what we have created with help of DI architecture we configured previously in our backend development, right? And we are trying to make a lifecycle cleanup as well. So that is what we did quickly in setup and global set. So now let's get into the agent test.ts. There was a power glitch, so I'm back. Hopefully I'm recording well. But yeah, again, coming to this. Now the overall idea is we have our service layer ready, we have our tools ready, and our database ready, right? Now how do we do an integration test on something which is a conversational in nature? LLM outputs what? Outputs a text format, a kind of a string format, without having to use a gigantic regex expressions to evaluate each output. What will you do? Let's say even if you have to use a regex pattern, what is that you will do? Will you predict each time what the LLM generates? No, right? You can't do that. Example, if I just ask the LLM, go ahead and add an expense a lunch at Subway of 12 rupees. If I just quickly say this to my LLM, what will be the output? It may at some point in time, it may say, okay, I have added this expense. If the exact strings are, okay, I have added this expense. Will you write every time whether the test will be deterministic in nature? What does that mean? Would you check for the literal string? Would you check for the literal string of what? Let's quickly say right here, right? Let's take a text input and write, okay, I have added the expense to the database, right, to the DB. This is the output that I got from my agentic graph or from my LLM. After once I perform, go ahead and add so and so price that I have made as an expense. So will you write an regex expression to each time to evaluate this when you run your tests? No, right? Each time this can be something else. It may just simply say, so that's what we say, that it is indeterministic, right? So next time it may say that quickly, it may simply say, okay, I have added, let's say simply as this much. Your test gonna fail and it will be a false alarm, right? Very simple. It will then be flaky as well, right? So how do you make sure this means one and the same? All that you have to do in each of this scenario, how do you deterministically test this? That is where the question arises, right? The question arises once it says in this fashion or either in this fashion or in any other fashion. How do I pass the test? How do I pass the test? One quick measure would be, irrespective of what it says, you can go ahead and check the database that particular expense got added or not. So that is what the first internal check would be. We will make sure that the side effect, we will say that the cross references of this assertion that it actually went, made a mutation in the test DB, in our test DB, and we fetch the record whether that particular new expense got added or not. That is the first level of test that we will do. Second, whatever the logical inference that it is trying to give out in a natural language way, we need to test that as well, because the inference and the analytics that we drive out of it should be relevant to the operation that it made internally onto the test DB. I will repeat myself. Whatever the action that the LLM performed on your test DB, in this case it was to add 12 rupees into your test DB, right? That you cross check that it really got added. Now the inference text that it is trying to give you out, the inference text here might be as simple as, okay, I have added, the addition is success, or something of a very generative message, okay, I have added the expense to the database. Whatever the inference that it gives in a natural language format, it should be relevant of what the action that it performed on your test DB. Fair enough? How do you judge that? You judge that with another LLM which is good at reasoning, right? And it will be less on your tokens, right? How do you make sure that it is less on your token? Since we will create one more node called as, if you just quickly go here, if I go to the test, we will make use of something of a util, where in this util I have written a judge kind of a node, where this judge kind of a node is something which is which can be a self-hosted, a reasoning model, which might be a lightweight, it's kind of not so token heavy. It might be self-hosted in your own enterprise data center, or something of a lower token consumption model. You can use such kind of a model, and what you can do, you can give it an evaluation prompt. This evaluation prompt need to be very careful. What are the things that this judge gonna evaluate across? It gonna evaluate what is the present input that I am trying to give to the actual LLM. What is the present DB state after that it executed that workflow? What is the DB state? And what is the agent response that it is trying to give out based on this? Now what you do, there is a criteria for this evaluation. What is that this judge need to judge across? Whatever you judge, however you judge, make sure that you give me an output in a pass way, saying that whether this particular test case passed and what is the reason for passing it. If it fails, more particularly, what is the reason, a concise explanation of why it failed. Now, why is this important? This is what the indicator of your test getting passed or failed. Simple. What it did, we gave everything that is there. So we need to make sure that this particular judge model has what, as an higher context window, so that it can observe your input, your DB state, and whatever the agent response that it gave. Now you be the judge, this particular node be a judge, and say whatever the LLM is trying to say to us, whatever the DB state that got corrupted or got updated, is it proper? This is what the DB state looks like now after the execution, and this is what LLM has to say. Judge and tell me that whether whatever the LLM is speaking versus whatever the state that we have, is it correct and matching. That's where the magic lies. Now with that said, tell me in a correct 1 or 0 fashion whether the test is passed or it failed. Now based on this output, your CI/CD, if at all, if you have set up a CI/CD integration test line or a pipe which takes care of sanity checks, right, for your LLM, this is what it gonna refer. This is where the detrimental whether this test passed or not, based on this boolean value. That is how simple that we can write a judge, where we will do an evaluation. These are called as evaluation, and there are certain metrics for evaluation which we just saw, right? So if we quickly go to the LLM tests, so if you see this, let's go a simple one. Let's take a simple one. What is that it is trying to do? Should call a tool add expense and pass the LLM judge evaluations, or it is called as eval. So what is the user input that we are trying to pass? We are saying that lunch at Subway was 12 rupees, and invoke our actual expense agent, right, with this particular human message. Now we invoked that and we got the response back. Now once we got the response back, a deterministic assertion, right? This is entire evaluation is non-deterministic assertion, but this deterministic assertion is to cross-check that in the DB. So we cross-check that it really got appended or not. This is a conventional v-test, an assertion test, right? Now after that, we invoke our LLM judge with what was the DB record inserted, did the agent answer the user. We say that much and see whether the expected value, the judge passed it or not. This is a structured output. If you see in an LLM, we do something called as a structured output. We are asking the evaluation judge to give us an evaluation output in a structured format, which is evaluation result pass. That is something which LangChain and LangGraph has to offer, or any agentic framework has to offer. That is LLM's output in a structured JSON format, so that we can deterministically assert in this case, right, it passed. So if it failed, then the entire this particular test gonna fail with the appropriate reason. Now if this fails in a CI/CD pipeline, my particular one test failed, I can unmerge the PR or not make that release to happen, something of that sort you can take care. So that is how we make a LLM as judge kind of evaluation in our agentic in our agentic flow. So we use to judge a non-deterministic system where it can be generative in nature. We use another undeterministic node where it is a better judge of what it is trying to consolidate, and also along with that we check our state on our DB as well. So one deterministic check that is on our DB, and the second one being on our judge to generate to assert the whatever the generation that our LLM has made, right? This is how you perform an integration test in case of agentic graph. That's one, right? So now quickly let's see how we can do the agentic graph standalone test, that is unit test. For that, something which I haven't written here, what we can try doing, what is the outcome of it? See, even in this scenario, when we write an integration test suite, we can mock up the agentic graph to be pointing at what? since we at the runtime we can provide LLM as injection. See, if you go here, my agent expense, where it is in my source, in this particular my agent, what does it expect? It expects LLM as my input. So I can literally mock this LLM to be a non-production version where I could save my tokens of hitting the production variant, right? So I could save, it can be a self-hosted one where still I am running, there is an infrastructure cost to it, but then it is not the production cost that I am trying to incur, right? That is one stuff. Otherwise, what you can do, you can mimic all the possible outputs for this. In our setting condition, there will be arrange, assert, and all that 3 steps, right? We can mock up what particular tool that we are trying to see, we are trying to call, and what will be the output of it. It can just simply mimic back as if the LLM is speaking to us, right? We can just do that as well. So with that unit test, what is that you gonna evaluate? You will evaluate whether this graph, this particular graph logic, right? This graph logic, as in the routing logic, is proper or not. So you will have a test without having to have an additional token up burn. You are just trying to unit test the graph. It might be a bigger graph. You might be having a sub-agent system with you where 2 or more agents are trying to correlate. So in that case, how do you check? How do you make sure that the routing is happening properly? If there might be a simple error over here, there might be a simple logic check over here that it is not leading to a tool node where it was supposed to be have called the tool node. How do you have a failure condition for that? How do you have the test written up for that? It is to mock the LLM. So mocking the LLM and writing the unit test for only agent will give me a graph testing capability. Writing only for the tool and mocking all the service layer will harden my tool, which is to evaluate the Zod schema. If I have to write an integration for the tool, it will give me the confidence on my entire tool to service to repo flow. And if I have to write an integration test, that is LLM-as-Judge, for my agentic graph, it gives me a confidence of having what? Having a non-deterministic node in my entire agentic workflow, right? This is how at the very beginning, at least, we can start writing a test cases for an agentic workflow, right? That is what we have written here. This is something which I have written here as outcome evaluation, the judge. So define judge node, right, which we created the judge node there. Cross reference assertion, that is cross check that whether the database it is speaking the truth or not, whether the LLM is speaking truth or not. Then pass that DB state along with whatever the LLM gave as an output, the generated output, and determine, ask the judge to evaluate a binary pass or fail. With that, your test passes or fails. That is how we have written it, right? Next is that route and graph validation. That is basically for your mocking the LLM for unit testing your graph. That is something which we covered extensively here now. So these are 3 checkpointers for any development. Either you employ TDD or you are trying to do it at the later point of time. Make sure that you have your tool tests ready, be it integration or the unit test, and graph unit test and the integration test ready. That is how you attain kind of at least in a reliable, non-reliable word of LLM, you have a reliable test case. If it fails, we have our CI/CD setup, we have our test suits set up. That gives out an indication that certain things are going wrong because of this refactoring that we just did, right? Now, typical last step of our video is how do we make a one TDD workflow. Right now, what are the tools that we have? If you just quickly and see, if you go quickly and see this tool, so we have just add expense, we have get expense schema and get expenses, right? So and generate chart. We do not have. So basically, what is the capability of this agentic particular this agentic AI has? It has an ability to add expense. It has an ability to fetch the expense and make an analytic run upon it. Now, what if I want to delete that expense? Now that particular feature is not there. Let's say on our existing flow, on our existing system, we got this requirement or a feature development. What will we do? we will do a TDD workflow here. How do we go about approaching this TDD workflow? What is that? First what we will do, we will write the test case. So quickly, we will not do a development since we are in test driven development. What is that we will do? We will go to our tests first, go to tests first, check where the tests, let's say we are trying to do an integration test or integration test at a level of LLM, let's say, not at the 2 level. If you want to go at the 2 level, you can go at the 2 level and add a one more, let's say, delete expense test suite where you will be writing the test for that. Let's say now I am trying to do at an LLM, right? It's a hole to hole on a test DB. We are trying to integrate this particular tool, an enhancement request. So I'll go to this agent test and I will write up like I have written should add this expense. What I will do, I'll quickly make a copy of this, right, and add up one more test case of it should call a tool to delete the expense and pass the LLM-as-Judge, right? First I will write this. What is that? What is the arrangement that I will do? The arrangement is I have to add certain expenses in the DB first and try to insert that into DB. Only then it can go ahead and delete. So let's say I have added groceries and Netflix and I have added that into the DB, right? Now what I will do as an user input, go ahead and delete my last expense. Which was the last expense? Let's say it was Netflix. So ideally what should happen? It should have deleted. Since I haven't made any development, since we are at TDD level, it becomes a red. The test will fail, right? That the result is the test fails because the tool doesn't exist. Now what is that now I have to do? I have to quickly go I have to go to server, right? In the source, I will go ahead and add one more tool to my tool arsenal, right? I'll just copy this and add up one more tool to it, where in this tool I will particularly call up a delete service. If the service itself is not written, go ahead and write. I will touch across all the layers, right? I will add up the tool with Zod schema. If the service is not there for the delete expense, what I have to do, I have to write up the delete expense. If there is no repository layer that has been set up, I will do that as well. So the entire development now will be done as part of this. Now agentic graph, all that it has to do is it got added with one more tool, that is to delete. So that is what the refactoring that I did. So what did I do? I defined the Zod schema with a particular expense ID, because to delete it I need an expense ID. So I will implement the delete expense method in my domain service if I haven't done that already, and wrap it in the agent's tool interface. So now that tool is given to my agent. So that much is done. Now what I will do, the test case which I wrote, I will rerun that, whatever the test suite that I wrote, right, for this LLM, I will rerun that. What will happen then? It should become green because now the test is there. LLM is trying to identify that. If there are certain hallucinations or if there are certain things, you now can catch hold of it, right? Since we have implemented, it should find that particular tool. Now what should LLM, since we are writing it, this is at the tool level, if you are writing it for the tool, right? If you are writing it for the integration test suite, what will the LLM will do? Will pass that particular test and say that particular expense was there to begin with, now it got deleted, and your LLM is speaking truth, saying that it really got deleted. So that the test is passed. That's how we quickly go about doing a TDD flow. If there are further refactoring, if you are not satisfied with your development, you can always refactor. Now for this refactor, what we will have is, we will have a one test route always checking. If at all, if you just make a mistake, if you made a mistake previously, this was green, right? Now in this flow, we attained that the test passed. Now that's a solid proof that it was working. Now you went ahead and then made a minor refraction. You did a minor change. What will happen? That minor change is a breaking change. What will happen? The green will turn to red. So that means your test failed. So any refactoring errors now within immediate effect or in the future will be detected. That's a typical usage and use case of any tests, right? So you can confidently refactor your code even in case of an agentic flow, is what we are trying to come across. So a typical flow will look like this. Is how we do a TDD workflow in agentic for adding one delete expense tool. Maybe at any point in time, if time permits to me, I'll try to quickly code it up, live coding. I'll try to do a live coding and try to add a delete expense as a tool into this repo and see how, since I have already set up everything for this, so now it should be quickly adding up a new test case and seeing how do we perform TDD upon this, right? We will try to do at later point in the playlist somewhere, but as of now we are theoretizing this, trying to understand how did we do, how can we test in our agentic workflows, right? So this is something which I have written for the entire architecture, right? The architecture is, first you have to do mock an LLM. If you don't want to burn tokens, you can just mock LLM, use a local model, or you use a mock LLM capabilities as per the tool or the test scenario that you are trying to evaluate, which simulates your you simulate your input, it simulates the output that is generated out of your LLM, right? And check whether did it make a schema check. You validate it against your in-memory whatever the in-memory or a testdb database that you are trying to verify through. How did it do? It did through its domain service flow, right? And the final state is something which will be evaluated by whom? Which will be evaluated by your LLM-as-Judge node. It is trying to cross-check your database, your LLM response, and say whether it has been passed or failed. So then we have a production ready agent which is tested, which is reliable now. So the goal was to decouple the brain and the logic, which we did as part of our backend architecture. Now what we are trying to do, we are trying to reliably make a quality assurance of it without having to additionally burn tokens. When you target the test only for the tools, are we burning the tokens? No. If I do a mock agentic graph, since through IOC and now I am able to mock the LLM as well, will I burn the tokens? No. Even if I have to burn the tokens, it will be the tokens of what? It will be a token of my own self-hosted LLMs, which can, even those self-hosted small reasoning models can also execute such flows. So it will be only infrastructure cost. So that is what something of a goal for an agentic red to green refactoring, or TDD you say, or testing your agentic workflows will be. So yeah, that concludes majorly the theory part of our agentic tests, right? I will try to give this repo examples as I told before, and also this to do, so that you can refer. If you have any comments upon how you are trying to improve your agentic test suites, if you have a different approach, please leave a comment over here, right? And I'll try to incorporate that as well. It's a living document. I want to improve this document at any point in time, right? So yeah, that's all, and thanks for sticking so long. Thank you.